everyone. Today we're going to be talking about linear versus exponential graphs. So the first thing that we need to know is that linear and exponential equations are two different things. Linear equations have a form of y is equal to mx plus b. We've talked about this earlier this year. It creates a line. So that line might look something like that. It's straight. It's a straight line. It has a slope. It could be a positive slope or a negative slope. It could be a zero slope, which would make a straight horizontal line. And linear functions represent something that you're adding to every time. So if I added 1 every time, that would create a linear function. If I added 2 every time, I would create a function. If I added negative numbers, it would create a function. As long as I'm adding the same number every time, it creates a linear function. And then exponential functions are in the form y equals a times b to the power of x. And we've talked about these also previously, but in exponential functions, you're multiplying by something every time. So instead of adding 2 every time, you're multiplying by 2 every time. And exponential functions end up getting really, really big really fast or really, really small really fast. And so they kind of look like this when you graph them. Either like that, or they could come down like this. So those are both exponentially functions. So in this self-check, what we're going to do is use tables or use graphs and tables to fill out the graphs and then determine what kind of function it is. So for the first example, it gives us this equation, gx is equal to 1/5 x minus 1, and asks us to fill out the table and then graph it. So when I fill out the table, it gives me all of the x values that it wants me to use, and so all I'm going to do is replace the x in my equation with those x values and get an answer for y. And so I would have g of x, if I plugged in -3, would be 1/5 times -3 minus 1, which, once again, you can do this by hand, but the calculator is going to be your super friend in this case, and it would be negative, like I'm going to keep these, we could put them in fractional form, but I'm going to keep them in decimal form. This would be -1.6. Then I'm going to do the same thing, but now I'm going to replace the x with -2. So like this would just change to a 2 right here. And that would give me -1.4. Now I'm going to change that to -1, which would give me -1.2. Now I'm going to change it to 0, which would give me -1. Now I'm going to change it to 1. And you continue to do this until you have the table filled out. When I have it 1, it's going to be -0.8. When I plug in 2, it's going to be -0.6. And when I plug in 3, it's going to be -0.4. So we have this whole table filled out. That's great. Now we can use the table to graph. So when I graph this, -3 is when x is -3, y is -1.6. So I'm going to go out to -3 and then down to -1.6, which I know my graph's not great, but your graph will be a little bit easier to do this on, which is about right there. And then at -2, it's -1.4, which is about right there. They're really close together. And then at -1, it's at -1.2. Then at 0, it's at -1. Then at 1, it's at -0.8. And it just kind of keeps on creeping up a little bit, but it's a really, 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 really thin slope. It looks kind of like that. And I know, once again, that it's a little bit harder to see because my points are so close together, but it doesn't curve up or down, which means it makes a straight line, right? When it makes that straight line, it is considered linear. The other thing to look at is the equation. The equation is in that y is equal to mx plus b form, which means automatically I should have known that it was linear. So for the example number 2, it's asking those questions. The first question it asks is, what type of function is it? And my 2 options are linear or exponential. And because it creates that straight line, because it's in the y equals mx plus b form, I know it's linear. And then the next question that it asks is, what is the rate of change? So the rate of change, that's just a fancy way of saying slope, or what is it changing by, what is it adding every time? So in this case, my rate of change, which is the slope, is the number in front of the x, and that is 1/5 is equal to my rate of change. Okay, so now let's look at the next example. And in this example, it doesn't give us an equation, but it asks us to fill out the rest of the table. So in order to fill out the rest of the table, we have to figure out what's going on. And the way that I like to do it is I like to look at my y's and I'm saying, okay, I'm going to go from 1 to 3, and then I go from 3 to 9. The first thing I'm going to look for is if it's adding something every time, because that's a little bit easier to see. So from 1 to 3, I would add 2, but from 3 to 9, I add 6. So because I'm adding 2 the first time and then adding 6 the second time, it doesn't make sense. You're adding something different every time, which means it can't be linear. It has to be exponential, because if it's not adding something the same thing every time, then it has to be multiplying by the same thing every time. So let's see if it's multiplying by the same thing every time. So 1 to 3, what would I multiply by to get from 1 to 3? I would multiply by 3. And then to get from 3 to 9, I also multiply by 3. To get from 9 to 27, I also multiply by 3. So this is obviously exponential because I'm multiplying by the same thing every time. So what I'm going to do now is continue to multiply by 3 so that I can fill out the rest of the table. So from 27, I'm going to do 27 times 3, which gives me 81, which would go in the next slot. And then I know that the rest of your X table isn't filled out. We're just going to continue to go up by 1, so like 5, 6, and 7. And then I can continue to multiply by 81, or I'm sorry, multiply by 3. So now I'm going to do 81 times 3, which would give me 243. I would give it 243 times 3, which gives me 729. And then 729 times 3, which gives me 2,187. So obviously it got really big really fast. And that's another marker of exponential equations, is that they get either really big really fast or really small really fast. So now when we go to graph it, we know it's at 0, 1, which would be right here on my y-axis. And then the next point is 1, 3, which is right here. And the next point is 2, 9, 6, 7, 8, 9, which is right here. And that's like as much as I can go. Now, I told you at the beginning that the exponential equations kind of like bottom out, like on the other side. So this kind of looks like this on the other side, and I know that there's not necessarily enough space to do that, but I just don't want you to think that it's like a straight line. It is actually a curve that curves up. And so for the example number 4, it's asking what type of function it is because of the way that it curves, and because we know it's multiplying by something every time. We know that it's an exponential function. And then it also asks what the rate of change is. So in this case, in the last case, it was the slope, right? And that's what we were adding every time. When it's an exponential equation, the rate of change is what you're multiplying by every time. And so based on what we know about this table, we're multiplying by 3 every time, which means my rate of change is 3. And this is how we graph and compare exponential and linear functions.